Today we're going to learn about basic properties of logarithms. Last class period we learned how to evaluate them using our exponent tables and some of its basic rules in writing it. Today we're going to learn about some of the basics of how to combine them using different properties. There's three major rules that we're going to use. One's product property, which basically says if you have two values multiplied together, m and m, you could actually separate it into two logarithms by placing an addition sign in between the two. So multiplication becomes addition. Same thing as multiplication, division has its own rule. If you have a log of two values divided, you can actually take the log of the numerator and subtract the log of the denominator from it. Now the last rule is the power property, which states that if you have a power, you can take it down from being an exponent and put it in front and make it a coefficient, which we kind of practiced that last class period. So for the first few, I have three examples here. I want to evaluate these. Now if you look at all of them have a base 2, but none of their solutions are values we can find on our exponent table. So what we're going to have to use is we're going to have to use the product and quotient rules in order to find these values. The first one, log base 2 of 3/7. When I think about that, I think of 3 divided by 7. Now, what we have to remember is both of those values are going to get a log. So log base 2, notice the subscript just tags along, 3. The division, if you remember back from the previous page, turns into subtraction. And then we just write log base 2 of 7. Now what this is doing is we're expanding it. We're making it bigger, but we're making it into numbers we know. Well, from the problem above, it says that log base 2 of 3 is 1 and 585 thousandths. It says minus log base 2 is 7, 2.807. So to finish evaluating this problem, all I have to do is subtract those two values. So using your calculator, you subtract them, or using your mental math skills, and you get an answer of negative 1.22. So I was able to find this problem's answer without actually utilizing some of the features that we have on our calculator, just using those basic ideas. So let's try another one again. This time we're going to do log base 2 of 21. Now 21 is not a division problem, so it doesn't help me. But I can look and I can say, okay, I have a 3 and I have a 7. How can I make a 3 and a 7, or one of those, become a 21? Well, I know that 3 times 7 is 21. So what we're going to do is we're going to expand it. We're going to say log base 2 of 3 and log base 2 of 7. And from the previous page, the product rule says that multiplication becomes addition when you expand it. Now all I have to do is plug in my given values. So 1.585 plus 2.807. We add those in our calculator or in our brain. And we get 4.392. So a little bit more than 4, not quite 5. 2 to the 4th is 16, 2 to the 5th is 32, which makes sense. That is going to be somewhere in between the two. Now, last one, 2 to no power gives me 49. So I have to break it up. Now, I could use 3s, but it might get kind of messy. But 7s are pretty easy to do because I know that 49 is 7 times 7. Which is basically 7 squared. So you could break it up like that, or you can use your product and power rule. So if I just do that, log base 2 of 7 to the 2nd, or you can break it up, bring the 2 down in front. So it's 2 times log base 2 of 7. Then all you have to do is plug in your number, 2.807, and double that to get your answer, which is the same thing as adding that value twice. That is why that rule works. Now let's look at a few more, just as a quick practice. Log base 6 of 5/8. Okay, 5/8 I know is the same thing as 5 divided by 8. So basically I have log base 6 of 5. Division becomes subtraction. I do log base 6 of 8. And then I just plug in their decimal values. So 0.898 minus 1.161 yields a solution of negative 0.263, which is actually the exponent. So if I took 6 to that value, I should get approximately 5/8. Okay, next one. Now, at any point in time, if you feel overwhelmed, pause the video, catch up, and then continue on. 40, using 5s and 8s only, I know is 5 times 8. Now, to expand this, they're both going to have a log base 6, but multiplication is going to become addition. Now, what happens when you do that is you have two values that you're going to add together. So 0.898 plus 1.161 yields a solution of 2.059, which is my missing exponent. 6 to approximately this value will be about 40. Okay, next one. Change up the color. 64. Well, I know I can't use a 5 to make 64, but I know 8 times 8 is 64. So you can either write it as the power of 2, or you could just break it up. This time I'm just going to break it up. Log base 6 of 8. Multiplication becomes addition. Log base 6 of 8. And then I just substitute in my value. In this case, 1.161 plus 1.161, which is basically times 2. Thus yielding an answer 2.322. That means if I took 6 to this power right here, I would get about 64. Okay, let's try one more of these and then we'll move on to something else. 125. Well, I know I can't make an 8 into 125. I know that 5 times 5 is 25. And I know that 5 times another 5 would be, or 25 times another 5 would be 125. So this is really 5 to the third. So if I write that, that's log base 6, 5 to the third. My exponent's going to come down in front using the power rule. So it's 3 times log base 6 of 5. So it's 3 times basically 0.898. Which is 2.694. So that's how we evaluate for given numbers, but let's do a little bit more. Let's change this and let's go into variables. Now remember from last class period, I explained that there was log and then there's natural log, or ln. Now natural log is just a special type of log. It's log base e. Anything we can do to log, we can do to natural log. So don't freak out if it says ln instead of log at the beginning. You do the same rules. Now the easiest way to do these is to consider the math problem at hand. It says expand. Expand means to make it bigger, which in our case that means we're going to have a bunch of natural logs. I have 5x to the 7th over y. Now what that means is 5 times x to the 7th divided by y. To expand, every single one of those values is going to get a natural log. So we're going to have natural log of 5. We're going to have the natural log of x to the 7th. And we're going to have natural log of y. Now what's going to change is the signs in between the two. Multiplication is going to become addition. Division is going to become subtraction. Now we're almost all the way done in this problem, but when you expand, you should be left with no exponents. So your last step is going to be to take anything with an exponent, such as this x to the 7th, and move your exponent down in front using the product property, or the power property, excuse me. So my answer is natural log of 5 plus 7 natural log of x minus the natural log of y. I have no more exponents. Every single number or variable has its own natural log. I am done expanding it. Okay, let's try a couple more. We're going to expand log base 6 of 3x to the 4th and natural log of 5 over 12x. Now, number 5, realize that 4 only goes with the x. Okay, that 4 does not go with the 3. The only way that would go with the 3 is if it was in parentheses. So what we have in this math problem is we have 3 times x to the 4th. So to expand, everybody gets a log. Now, what do I do with that little subscript of a 6? That's just my base, and it doesn't go anywhere. So it's log base 6 of 3 and log base 6 of x to the 4th. Okay, now I got to change my multiplication. Multiplication becomes addition. And my last step is any exponents I have need to go down in the front of the logarithm and make it a coefficient. So it's log base 6 of 3 plus 4 log base 6 of x. And I am done with that math problem. I have no more exponents and everybody has a log. Okay, let's try one more here. Natural log of 5 divided by 12x. So 5 divided by basically 12 times x in the denominator. Okay, that means it's natural log 5. Okay, and then we have division, which becomes subtraction. Okay, then I have parentheses. I have 12 times x, so that means natural log of 12. Multiplication becomes addition, natural log of x. Now I'm not quite done on this because we have two quantities, or we have a binomial here that has a minus in front. So your last step when you have multiple values in the denominator is to distribute that negative through. So it's natural log of 5 minus natural log of 12. Minus the natural log of x. So basically anything in the denominator, well, even if it says multiplication, is going to end up as subtraction because you're dividing by it. Cruising right along. Here we go. The opposite of expanding is to condense. So if you look at this problem, instead of one log, we have multiple logs. So what we want to do is rewrite this math problem so that it's no longer multiple logs. So to do this, we write log once. Okay, now what I'm going to do is I'm going to combine everything I know. So log of 9 is just log of 9. Addition becomes multiplication. I have 3 log of 2. So what we do first is we bring the 3 up as our exponent. So that becomes 2 to the 3rd. So really it's not 9 times 3 or 9 times 2, it's 9 times 2 to the 3rd. Subtraction becomes division, and then I have my 3. Now, when we condense, we want to reduce it as much as possible, so we need to go ahead and finish the math problem. 9 times 2 to the third is 8. So it's 9 times 8, which is 72. Now, if I take 72 and I divide it by 3, I get 24. So the answer to this math problem, when condensing just numbers, is just 24. It's not 9 times 2 to the third divided by 3. Go ahead, if it's numbers, and simplify it completely. Condense it to a single number. Okay, we have a few more of these to try. Here's a couple more examples. Example 7 says log of x minus log of 9. So first thing we do is write log once. Okay, now I'm going to put anything that exists inside parentheses. So it says x. I don't see a number in front of this log, so that's no big deal. Subtraction becomes division, and then we list the other value, 9. Now, x divided by 9 is not 9x. Rewrite your answer as a fraction. So it's x over 9. That is what the value is condensed. Okay, let's try one more. Natural log of 4 plus 3 natural log of 3 minus the natural log of 12. Step 1 to condense is you want to pack up any exponents. I see a 3 in front of my natural log, so what I'm going to do is bring that up as a power. Okay, write your natural log or log exactly once. Put your parentheses in. First number is a 4. Addition becomes multiplication. We have 3 to the third. Subtraction becomes division, and I see a 12. So then in my brain or my calculator, I take 4 times 3 to the third. 3 to the third is 27, so it's 4 times 27 divided by 12, which is 9. So when at all possible, if it's just numbers, go ahead and simplify completely. Now, all these are good and great, but the problem is on your calculators, the majority of you don't have a fancy calculator that will calculate for any decimal form of a value. Okay, we can use our log key or our ln key to find anything that is a base 10 on log, but the problem is not all bases are 10. So the last rule that I'm going to teach you is what's called the change of base formula. Basically what that says is if you have a log base c of a, you can actually change the base to be whatever you want it to be, so long as your final answer is a log base b of a is divided by log base b of c. What in the heck does that mean, Mrs. Doran? That means basically if you take the log of the solution, which is your a, and you divide it by the log of your base. Sorry, in this case, my base was a c, which is your base. You will get the answer. So we're just going to try a couple of these. So you're going to need to bust out your calculator for this. So the first one we're going to do is evaluate log base 3 of 8. 3 to no power gives me 8. I know 3 to the first is 3. 3 to the second is 9. So that does not help me. I know that my answer should be 8, so it's probably closer to the second power, but I'm not quite sure. So what we do in our calculator is we take the log of our solution, 8, and we divide it by the log of our base, which is 3. Now, why am I doing that? Actually, by doing this, I have changed it so that both bases are base 10 because my calculator is base 10. So to enter this into your calculator, you do log parentheses of 8 in your parentheses divided by log of 3. So log of the solution divided by log of the base. So log of 8 divided by log of 3. Sorry for the phone ringing. You get 1.893, which we said was pretty close to 2. Not quite, but pretty close. Let's try one more. Okay, this time it says do the same thing but use natural log. You got to remember natural log is just a special type of log. So anything you can do to log, you can do to natural log. So when they say evaluate using natural log, log base 6 of 24, yeah, you could do log of 24 divided by log of 6. That would be just using log. But actually, you can also get the same answer by taking the natural log of the solution and dividing it by the natural log of the base. Because natural log is just log base E. If I do log of 24 divided by, ending my parentheses, log of 6, I get 1.773. If I try it using the other one, ln of 24 in my parentheses, divided by ln of 6, or natural log, I get the exact same answer. No different. So it doesn't matter on these whether you use the log key or the natural log key, you'll get the same answer. Ladies and gentlemen, that kind of ends all of our properties on logarithms. So, that being said, it is the end.